Okay, today we're going to talk about polynomial long division. Before we do polynomial long division, how many people remember how to do long division for regular numbers? Yeah. Good. Let's do a problem together because you will find that they are very similar. Okay, guys? So it is very similar to doing a long division for regular numbers like this. So let's say that I want to divide 433 by 27, right? So what you do is you first look at, well, 27 and 43, right? Don't you look at 43? Because first you look at 27 and 4. Does 27 go into 4? No, so you look at 43. How many times will 27 go into 43 without going over? Yes, sir? Once. So let's write it down, 1. And then of course you write 27 right here. Now what do I do with, this is important, what do I do with 43 and 27? We subtract. Okay, so please keep that in mind. I'm even going to do this. Minus, right? The whole thing is subtract. Okay, so when I subtract this, what do I get? 16. Alright, does 27 go into 16? No, it better not, because if it did, then the number that we chose is too small. So we bring down the 3, right? Because now 27 does not go into 16, so we bring down that 3 down here. How many times does 27 go into 16? I mean 163 without going over? 5 times. It's actually 6, okay? 6. Right? So it goes in 6 times. What do we get here? 162, doesn't it? Right? Yeah. Okay, so when you subtract, again, don't we have to subtract these? Okay, so when we subtract from top to bottom, you have 1 left. Now, sometimes you get a remainder, sometimes you don't, depending on kind of the numbers you get. Same thing with polynomial long division. Okay, sometimes you get a remainder, sometimes you don't. All right. How do we write down the answer? Then what is our answer? How about, pick somebody at random. How about, give me a sec. How about Joseph? What do you think?
16.
Yes, 16 and, do we just write 1? What do we do with the remainder? 16 and 1 over 27. Isn't that what we write?
Yes.
Right? Remember, you guys have, whenever you have a remainder, it's 1 over 27 is what's left. Correct?
Oh.
By the way, what does this mean? What operation is between this mixed number? Is it times? This is only exception. Very good. If you have 2 numbers, right? Many times, if you have x, y, you know that it's multiplication in between those. But this is one exception. When you have something written in mixed expression, it's not multiplication, right? This is one exception. This is really 16 what? Plus 1 over 27. Isn't that what it means? Okay. So please remember that this is what it means. But normally we write it this way, but that's what this means. Okay. All right. Are we good? Now we're going to be doing the similar thing with now, instead of just number divided by another number, guess what we're going to have? Polynomial divided by another polynomial. Is exactly right. So here is a question. I have 19x minus 21 plus 12x squared all over 4x minus 3. Class, I'm going to, and then look at the instruction. Most of the times you will try to factor the numerators and so forth and cancel things out, right? But I'm just going to ask you to divide. Okay, so if I ask you to divide, you'll be doing the long division. Is that okay? If I say simplify, then you try to factor the numerator and so forth and try to simplify. But if I ask you to divide, I just want you to do the long division. So what goes inside the division box? Yes, sir?
19x minus 21 plus 12x squared.
Exactly. The one on the numerator goes inside the box. And what are we trying to divide this number by? Yes, sir?
The denominator?
The denominator, 4x minus 3, correct? So that comes out of the box. Okay, be careful. Don't mess this up. Okay, then you're not going to get the right answer. Yes? Thank you. Do we want to leave it as this way? The numerator? No. Every time you deal with these, especially for long divisions like this, you really want to write things in standard form. Okay? So, I'm sorry? No, okay. Yeah, if I said to simplify, you try to factor. But then if I said to just use long division, you just divide. Okay? So here we go. First, very good. Samuel's right. You want to write things in standard form first. Well, denominator is already in standard form. That's okay. Numerator is not, so as I write this down, I wrote it in standard form, and I put it in the box like this. Okay. And so let me show you how similar this is, right, as when you're doing the long division with numbers. So guess what we're going to do? We're going to look at 4x minus 3, and I'm just going to look at the first term of the trinomial. I want to get rid of this trinomial, right? 12x squared. Why do I need to multiply 4x minus 3 so I could get same as 12x squared? In other words, how many times will 4x go into 12x squared? That's what we're asking, right? Is it 3 or 3x? We need 3x, thank you. So write this down. So I'm going to write it above 19x because I'm looking at binomials at a time, right? Does that make sense? So no, I have a binomial, right? And then I'm going to just look at these two binomials right now. Like this. Right? And then how many times is 4x going to 12x squared? I'm going to write 3x right above this. You know what I mean? Yeah. So that when I multiply, what do I get? Somebody tell me. How about Lindsay? Good. That's what we wanted because they're going to cancel out what? And then, of course, don't forget to multiply 3x with that negative 3, right? You're multiplying this binomial times that number. What do I get? Minus 3x. Very good. Minus 9x. You're right. Sorry. You're right. Be careful. Okay, are we good?
Yes. Yeah. Oh, it's easy.
Isn't it so much easier to just
What? Hold on. Let me.
Guys, look.
Okay, hold on. I want you to discuss with your group. See how we got this. I'll wait. So those of you that said you didn't get, basically what I did was I multiplied 3x times what, class?
4x.
Thank you. 4x minus 3. You want me to show that work? Okay, I could do it over here. What is 3x times 4x minus 3? You have to distribute this, right? You get 12x squared, what? Minus 9x. That's how I got 12x squared minus 9x. That's what we're doing. And that's what we're going to subtract from the top, just like how we did it before. So now, please write this step. Any questions so far? Does this make sense? Do you see where I got 12x squared minus 9x? Yes. I am multiplying 3x times that binomial. Yes?
Why?
Because that's how you do the long division, polynomial long division. Whatever you're trying to divide it by. Look, isn't that what we did here? Look up here. When I had 27 times 1, we wrote 27. We wrote multiply 1 times 27. Instead of one number, what do we have now? We have a binomial. So you need to multiply 3x with that whole thing, binomial. Does that make sense? It's the same thing. Yes?
But doesn't 3 go in 19 more times?
No, we are only concerned with the first term. Very good. So I just want to get rid of the first term. Don't worry about the second term.
Then why don't you put the 3x over the 12?
You could do that, but I'm just looking at 2 terms at a time. Because then it will line up. You see how it will line up with 3? You could put 3x up here if you want. It doesn't really matter. So if that makes more sense to you, that you could do that. It's not. It's a minor thing. Yes.
Now, how when you subtract 12x squared minus 9x, won't the 9x turn into positive?
Exactly right. So that's what I wanted to show. So, am I going to just subtract 12x squared minus 12x like this, or am I going to subtract the whole thing?
Oh, you're going to subtract
The entire
Yeah, entire thing. So I'm going to please write this down. Please put parentheses and put minus sign like this, so that you know you're subtracting the whole thing. Is that okay?
Oh.
Okay.
Oh.
Let me finish.
Oh my God.
Okay. Are we okay? Then you're going to subtract. Now, I even have a better suggestion. After you do this, because people make this mistake so many times, do I like subtraction?
No.
Could we always change subtraction to addition?
Yeah.
So look what I'm going to do. I'm going to rewrite this as addition, right? And what would this turn to?
Negative 12x.
What would this turn to? Okay, now I could just add. So even though we're subtracting, I even do this step because I'm telling you, so many times people forget to distribute the negative to the second term. So when I add them together, well, of course they cancel out. That's why we chose 12x, right? That's why we chose 3x. What is positive 19x plus positive 9x? 28x. Okay? Right? We're just subtracting top to bottom, right? But because I don't want to make mistake, look what I'm doing. I am distributing that negative 1. Because subtracting is the same as adding the opposite, right? So I'm just writing the opposite. Same. And then you bring down, okay, of course, 4x minus 3 does not go into 28 only. You need 2 terms, don't you? So guess what? I'm going to bring down the negative 21. Not 21, but negative 21. Now, if you wanted to, you could have rewritten this as a addition, right? So, okay, and in between all these terms, you're going to put addition. It's going to be addition between all these terms, okay, on the top. Now, what do I need? 4x times what gives me 28? 7, correct? So, what do I end up getting here? 28x. What is 3 times 7? Minus what? 21. And look what happens. I'm going to subtract them, right? What does it mean to really subtract the whole thing? Well, it's adding the opposite of this thing. Plus, this turns into its opposite, minus 28. Not only that one, but this also. Right? When you add them together, what do you get, guys? What do you get? 0. So this time, did it have any remainder? No. Is that okay? Sometimes you get remainder, sometimes you don't. So what's your answer?
3x plus 7.
So how many times, look, how many times does 4x minus 3 go into this trinomial? 3x plus 7 times. Is that okay?
Yeah.
Alright, very good. Okay. So we had some good questions. Some of you said, don't we have to worry about this 19x? No, we have to just worry about the first term and the first term. Don't worry about the second term, okay? You just want to get rid of the first term. Every time you do this, you want to get rid of the first term. Second question is, well, couldn't we have just factored the numerator? Wouldn't that have been a lot easier? The answer is yes. But will you always have something that you could factor? No. Okay, so if you could factor, normally you would just factor and simplify this way. But many times you will get a trinomial that you cannot factor. In that case, you will be doing the long division. Okay. Or sometimes if you forgot how to factor, if you factor this way, if there's no remainder, you know what the answer is also. Okay, does that make sense? Okay. So I know that this is first time you're seeing it, most of you. So I want you to do this yourself. It may be a little confusing at first, but as you get used to this, you will see that it's the same thing, same exact thing that we did with the numbers. Okay. So here's example 3. Negative 6 plus n squared plus 5n over n plus 6. Okay, it says to divide. That means do the long division. By the way, is the numerator written in standard form?
No.
No. So do you think you should write it in standard form?
Yeah.
Okay, everybody go ahead and try. I'll give you time. See if you could do exactly what we did with example 2. Okay, go ahead. Everybody try. So how many people wrote the numerator in here in standard form and the denominator outside the box? Very good. So now I'm going to look at n and n squared. Really, that's what I'm looking for, right? So what do I need to multiply n so that I get n squared? So that I need to cancel out that first term, right? N. So I'm going to write n up here. Is that okay? Then I get, of course, n squared plus, what is n plus 6 times n? N squared plus 6n. And what am I going to do with this from the top? Subtract. So I'm going to put the whole parentheses here. I'm going to be subtracting this. And I have to remind myself, okay, subtracting is adding the opposite. So I'm going to put addition, minus, and then minus, negative 6, right? Opposite of whatever that was inside. So then when I add them together now, I get 0. What is 5n plus negative 6? N. Is it 1n or negative n? Okay, negative n. Be careful. Okay. It's negative n, guys. Right? You're adding the top to bottom now because we changed everything to addition, right? Plus, of course, you need to bring down the negative 6. I change it to addition. Okay. Now I'm looking at n and negative n. What do I? Okay. So between these terms on the top, it's always addition between them. Okay. What do I need to multiply n so that it becomes negative n? Yes, sir.
-1.
Negative 1 is what I need. Can I put 1? No, then they won't cancel out, right? So I need to multiply negative 1 to n so that it equals the same thing what I had up here. So I get negative n plus negative 6. And of course, I'll be subtracting these. Right? So therefore, when I do this, so subtracting is really adding the opposite. So I'm going to change it to addition and then write as opposite in here. Positive n and positive 6, right? When I add them together, what happens? I get 0. So what is our answer, class? N minus 1 is your answer. So when you divide n plus 6, right? When you divide this numerator by n plus 6, how many times does n plus 6 go into this trinomial? N minus 1 times. Yes?
This is the best math thing I've ever done.
Really?
Yeah.
Very good. All right. Let's move on. Now, by the way, are you always going to have ones where there's no remainder?
Oh.
No. Sometimes you will get remainders, right? So let's do one where you get some remainders. Okay, here we go. Okay, go ahead and try example 4, everybody. Here it is. It's 4x cubed minus 2x squared plus 6x minus 5 all over 2x plus 1. It says to divide. So go ahead and divide. Okay. In other words, that means to do a long division. And yes, nicely they gave you to you in a standard form, right? Go ahead, everybody try. This time, I think you're going to get a remainder. Okay, so everybody try. See what you get. So, did you all write it this way first? Where you have the numerator inside the box and then, 2x plus 1 outside. Because that's what you're doing. So, I'm looking at 2x and 4x cubed. And I'm asking myself, what do I need to multiply 2x so that, it equals to 4x cubed? In other words, how many times would 2x go into 4x cubed? The answer is 2, what class? X squared, right? That would give me 4x cubed, right? 2x will go into 4x cubed, 2x squared times. So I get, let's multiply this binomial times that. I get 4x cubed plus 1 times 2x squared is, of course, is 2x squared. Now, what am I doing with this? I'm going to subtract from top to bottom. So I'm going to put parentheses and put minus sign and then subtract. Okay? All right? Okay? I get, so of course I'm going to subtract. So that means, remember, I don't like subtracting and people mess up a lot. So let's change everything to addition. Is that okay? So this really negative 1 times this whole thing, right? So plus, opposite of all this thing, this becomes negative. That becomes also negative. Be careful. This is where a lot of people messed up. People didn't do that and then got 0 here. That's wrong. You get 0 here, right? 4x cubed plus 4x. But here, what do you get? Negative 4x squared. Not squared. All right. How many people got this right? Raise your hand. All right. If you didn't, you're not gonna get this right. All right. I'm telling you, that's the place where most people make mistake. Okay. Then, hold on. Yeah, because you're subtracting from top to bottom. Okay. Now, okay. Here we go. Plus what? What do I write? Plus 6x. Okay. That's what's left. Any question? Is that okay? So then, what do I need to do? Plus, now, how many times does 2x go into negative 4x squared?
2x.
Okay, thank you. It's negative. I need negative 2x. Therefore, that's how I get negative 4x squared, right? So then, when I do that, I get negative 4x squared plus negative 2x. Isn't that right? But I am subtracting this whole thing, am I not? So let's subtract this whole thing. So that means this, everything inside the parentheses, right? Let's change it to addition. So this becomes addition, everything inside becomes its opposite. So now let's add. Of course, this is what we wanted. We wanted these first terms to cancel. Positive 6x plus positive 2x, what do we get? 8x. Right? Plus, of course, you need to bring down the negative 5 from the top here. Okay? Okay, that one, I brought that. Okay, so then, again, between all these terms, it's always addition, right? Why do I need to multiply 2x so that it becomes 8x? In other words, how many times does 2x go into 8x? 4 times, right? So therefore, when I do that, I get 8x plus 4, correct? And then, of course, we're subtracting these, are we not? Yes. So let's subtract these. Okay, then when you subtract these, it means adding the opposites, so plus negative 8x and negative 4. Class, what is negative 5 plus negative 4?
Negative 9.
Thank you. So you get negative 9 at the end. Okay, listen. Thank you. Thank you. So we get negative 9 out here. And now, here's the important part. How did we, let's go back to our first example. Do you guys remember when we had you know how we had a remainder of 1? Yes. The answer became 16 plus really 1 over 27th, right? Yes. We wrote down 1 over whatever you were dividing by. Yes. Guess what we're going to do with this? Yes, you're going to do the same thing. Good. So who could tell me the answer? How about, I'm going to call on Mimi. What do you think? The answer for this, it will be what? 2x squared. Mm-hmm. Plus or minus. So always between each of the terms is always addition, right? Plus what? Plus. Between each of these terms is always addition. Plus what? At the end, negative 9 all over. 2x. Yes, 2x plus 1. Does that make sense, guys? Yes. So in between each of these terms, guys, always remember it's always addition. Okay? Does that make sense? At the end, of course, you could simplify. Of course, this is plus negative 2x. So I can simplify this as 2x squared what? Minus, using the definition of subtraction, 2x squared minus what? 2x plus 4 what? What's this? Minus 9 over 2x plus 1. Yeah, at the end, you could simplify and rewrite this using definition of subtraction. But look, between each of these terms, always addition. Keep that in mind, okay? Are we good? Okay. Let's look at example 5. This is really important. This one seems very simple, right? It says y cubed plus 4 over y minus 1. And of course, well, we just put this in the parentheses, right? And then doesn't y go into y cubed y squared times? Look what happens when you do this. Things don't line up too well, right? You got 4 and then negative y squared. And then when you do this, things get really kind of hard because the like terms do not line up. So there's a trick to line up all the like terms. This is what you need to do. Notice the y cubed plus 4. Is that written in standard form?
Yeah.
Yes, but
Yes.
it's missing some of the terms. Which term is it missing? Y to the second power, because you have y to the third, right? It's missing y to the second. What else is missing? Y to the first, yeah, y.
Wait, what?
Isn't this missing some of those terms? Because, right? If you write things in standard form, don't you have to have decreasing order of the exponents? So where's the y to the second power? And where's the y to the first power? Right? That's the reason why things don't line up. So, well, there isn't. Yeah, they're missing. So what do you guess? What? In order for us to, so write this down. In order for things to line up, write this down. First, you want to write this in standard form using 0 coefficient for missing term. Please write that down. We need to fill in the missing terms with 0 coefficient. What do I mean by that? It's simply, anyone want to guess what I mean by this? Yeah.
Like the ones that aren't there, you use 0 because they're 0.
Exactly. Because look, this is what you do. And you might ask, why do we do this? I mean, isn't this just 0? 0 times y squared. What is that, guys? 0 times anything is? 0. What's 0 times the y to the first power? What's that? 0. Why do we even put that in? Well, because if you do it this way, guess what? All the like terms will line up. That's the trick. Okay? So if you do it this way, when you subtract top to bottom, all the like terms will line up. Otherwise, it's going to be really messy. Does that make sense? So let's see how this is helpful. So again, how many times is y going to y to the third power?
Y squared.
Y squared. And look what happens when you do this now. You get y cubed, right? Plus what? Negative, not y. Negative y squared. Isn't that right? And of course, we got to subtract the whole thing. Look, don't the like terms line up? You see what I mean? Okay. So when we do this, class, what do we get here? So what do we get here? Plus, negative, and positive, right? So we get what? Y squared. Plus, what's this? Well, 0 times y to the first is 0. So in between each of these is addition. What do I need now? Y. Very good. So you get y squared minus y. And of course, we need to subtract the whole thing. Put a parentheses. And let's change everything to addition. Plus, what do we get here then? Y plus 4. Okay, and then we need addition here. What do I need to multiply y so that you get y? Do I need negative y or 1? I just need 1. So I get y minus 1, right? So we're going to subtract this. When you do that, you get plus negative y plus, what do you get? 5. So that's your remainder. What's your answer going to be? Y squared plus 5. Plus 5 over. Alright guys, have a good day guys. Thank you.